Hi folks, today we're going to be talking about the organizing principles of the periodic table. So, before we get started, I'd like you to take a moment and pull out your own copy of the periodic table of the elements. We're going to be using it throughout this lesson, and you're going to be adding some things to it as we go. So, today we have a few goals, and you're going to need this for the class kick at the end of the lesson. So the first goal we have is to understand how to read a cell on the periodic table to determine its atomic number, its element symbol, its atomic mass, and its elemental weight. The second goal we have is to be able to use the periodic table to figure out how many protons, neutrons, or electrons an element has. And finally, our last goal is to be able to use the number of protons an atom has to figure out what element it is. So one thing I want to say before we get started is that there are lots of different periodic tables in the world. Many of them are designed for different people, and they have lots of different information on them. So looking at these periodic tables, you can see lots of them have all sorts of interesting things on them. This one's got an electron configuration written on it. You don't particularly need that, but if you were in high school chemistry, you might. Here you can see a different way of sort of showing how the electrons are arrayed. I don't even know what that piece of information is for. But all of these have some pretty basic things in common. You can see that on each of these periodic tables, the number 47 appears. 47 happens to be silver's atomic number, which is to say its number of protons. Now, on different periodic tables, it might appear in different places. So you can see over here it's in the top left corner, while here it's in the top center. It varies. You'll also see that each of these has the name of the element on it. So here we see silver up at the very top. Here we see silver at the bottom left. Here we see silver in the bottom center. Here we see silver. And you can see here, this periodic table is actually written in a different language. And so it says Silber, because that's the German word for silver. It's important to note that element names tend to vary from language to language, because many of these elements were discovered a long time ago. However, the element symbol is the same in every language. So the letters A, G, you'll notice the first letter, A, is capitalized. The second letter is lowercase. That's on each and every one of these periodic tables, even though one of them is in German. Now, oftentimes, that elemental symbol might be written, it might be the first letter or two of the element's name in English, but not always. So here you can see AG is an abbreviation for this in a different language, and we use that same abbreviation. So know that that symbol will be the same across cultures, while the name might change. Now we've got that atomic number, the symbol, the name. The last piece of information that's on here that you need to know about is the element mass. So you can see here we've got 107.87, 107.87, 107.87, 107.8682. That's the same number, it's just rounded to a different number of significant figures. Same deal here. So those same basic pieces of information tend to appear across periodic tables. What you need to do is learn how to recognize them on whatever periodic table you happen to be using. So the four pieces of information that I want you to be able to find are the atomic number, the atomic mass, the element symbol, that'll be either one or two letters, and it will be the first letter will always be capitalized. If there is a second letter, it will be lowercase. And the element name. So here, hydrogen. Now, what I want you to do now is I want you to add a key to your periodic table. So basically, I want you to take a moment and draw that hydrogen box that you have on your periodic table off to the left. So make sure you include that atomic number, the element symbol, the element name, and the weight. And then I want you to label each of those four parts of that cell in the periodic table. So just to give you a zoomed in version of what you're supposed to be adding to your periodic table, take a moment, pause this video, and add this onto your periodic table. When you're ready, you can unpause the video and we'll proceed. All right, are you ready? Let's move on. So the first piece of information I want to talk about is the atomic number. So you can find the atomic number on your periodic table because it's going to be the smaller of the numbers on there, and it's always going to be a whole number. So looking at this box, take a moment and think, which of those two numbers is smaller and a whole number? Well, 3. So what the atomic number actually means is the number of protons that atoms of this element have. So this element is lithium. It has 3 protons. Lithium is the element with 3 protons. If you have an atom and it has 3 protons, it's a lithium atom. Every atom with 3 protons is a lithium atom. I want you to take a moment, look at your periodic table, and find the very first element, element number 1. That element is hydrogen. It has 1 proton. Every atom with 1 proton is a hydrogen atom. Take a moment, look at your periodic table. Can you find element number 4? What element is that? Find its name. If you need a moment longer, you can pause the video, but you should have found that it is beryllium. So looking at your periodic table, you can figure out what element you have if you know the number of protons. Hopefully you also noticed that the number of protons, that's the main organizing principle here. The periodic table is arranged from left to right according to the number of protons on that table. So the first element is the element with 1 proton, that's hydrogen. The second element is the element with 2 protons, that's helium. The third element is the element with 3 protons, that's lithium. The fourth element has 4 protons, that's beryllium, and so on and so on. So it's the number of protons that determines what element it is. Now, the other thing that this atomic number tells us is the number of electrons. Now, the reasoning behind this is pretty simple. If I say that I have an atom, atoms we typically think of as being neutral. They have no charge. Their charge is 0. So if each proton has 1 positive charge, something like lithium has 3 positive charges. But it also has 3 electrons, 3 negative charges. So 1, 2, 3 negative charges. Positive 3 plus negative 3 is 0. It's neutral. It's a neutral atom. So in order for atoms to be neutral, there have to be the same number of electrons as there are protons. So a lithium atom has 3 protons and 3 electrons. So now you know how to find the number of protons and the number of electrons from a cell in the periodic table. Now, it's worth noting, there are also these things called ions. We'll spend more time talking about them later. Ions are what happens when an element loses electrons and no longer has the same number of electrons as protons. A good guiding idea to have in your head is that if I use the word atom, it's neutral, and there are the same number of electrons as protons. If I use the word ion, it's not neutral. The number of protons will still be the atomic number, but the number of electrons might be different. We'll talk about how to understand ions later. Remember that the periodic table is organized from left to right according to the atomic number, which is to say according to the number of protons. It might look like it's arranged by mass. It's not actually arranged by mass. It's just that because protons are heavy, if you increase the number of protons, you tend to increase the mass too. Speaking of mass, let's talk about that second number on the periodic table. So looking at any individual cell on the periodic table, you'll typically have 2 numbers. The smaller whole number, that's our atomic number. That's the number of protons. It's also our number of neutrons. It's also our number of electrons. And here we've got our atomic mass. You'll notice this number is bigger than the atomic number. You'll also notice that it has a decimal. It's really common for the mass to have a decimal. That has to do with isotopes and the fact that the number of neutrons can change. So this is really the average mass of an atom. Typically speaking, you're okay rounding this number. Now, what this number represents is the number of protons and neutrons that an atom has. So we've got 3 subatomic particles to think about: protons and neutrons, which are in the nucleus, and electrons, which are in the electron cloud, the area around the nucleus. Protons and neutrons both have a mass of 1 atomic mass unit. Electrons do have mass, but they're so tiny that that mass is negligible. It basically doesn't matter. It's small enough that you can ignore it safely. It would basically be a rounding error. So when you look at that mass number, the only two things that are adding to it are the number of protons and the number of neutrons. Knowing that, we can actually calculate how many neutrons an atom has. So you would start by looking at the atomic mass. So here I've got silver. Silver has an atomic mass of 107.8682. I'm going to round that mass to the nearest whole number, which is to say about 108. Then I'm going to subtract the atomic number, which is to say the number of protons from that. So 108 minus 47 gives me 61. So silver has 61 neutrons. Another way to think of this is that the number of protons plus the number of neutrons equals the atomic mass. So 47 protons plus 61 neutrons equals a mass of 108. So basically all we're doing is simple subtraction to figure out what the number of neutrons is for an individual atom. So at this point in time, let's think about our objectives. You now know how to read a cell on the periodic table to figure out its atomic number, that's the smaller whole number, its elemental symbol, that'll be either one or two letters, the first one capitalized that represents an element, regardless of what language it's in, the atomic mass, which is the bigger number, usually with a decimal, which is the sum of the number of protons and the number of neutrons, and the elements. Oh, I wrote element weight on there twice. My apologies. The next thing you should be able to do is you should be able to determine the number of protons, neutrons, or electrons that an element has. So the number of protons is the atomic number. The number of neutrons is the mass rounded to the nearest whole number minus the number of protons. And the number of electrons is just the same as the number of protons so long as we're dealing with a neutral atom. And finally, if you know the number of protons an atom has, that's the atomic number of whatever element it is. So you can say, oh, this has 6 protons, that's element number 6, that's carbon.